wants, big data, and machine learning. He's worked in security research for over 10 years and is a major contributor to several open source projects, including the Modern Honey Network, Binary Pig, Elasticsearch, and Accumulo. Just a little pro tip. Jason is also apparently an actor, director, producer, special effects artist, and screenwriter who has starred in all of the films that he has written and directed. He'll go check it out on Google. He'll try to throw you off by wearing an eye patch when he makes public appearances outside of his open source InfoSec capacity. But since you're at B-Sides, you're all cool, so we're letting you know and letting you all in on the secret. Please welcome America's next cinematic sensation, Jason Trost.
Thanks for coming out to my talk on lessons learned from building and running MHN or Modern Honey Network, the world's largest crowdsourced Honeynet. So he already introduced me, so I'm just going to kind of blow through this slide. I'm the director of ThreatStream Labs, which is the research and data science team at ThreatStream. Previously at Sandia National Labs, Department of Defense, Booz Allen Hamilton, Endgame, and now most recently ThreatStream. I've been working in security for more than 10 years now, focusing mainly on building distributed systems, doing big data security analytics, and then most recently moving into security data science. I'm also a big advocate of open source and open source technologies. I'm a big open source contributor as well. He mentioned the projects that are also listed here, so I won't go over them again. So who's ThreatStream? ThreatStream's a cybersecurity company that was founded in 2013 and venture-backed by several prominent venture capitalists. We have a SaaS-based enterprise security platform that enables our customers to manage threat intelligence data. Our customers hail from the financial sectors, retail, energy, and technology. Okay, so here's the agenda for my talk. I'm going to go into a brief intro to honeypots, for those of you who don't know what they are. I'm going to talk about the Modern Honey Network, or MHN. I'm going to talk about the MHN community that's been built around this system. I'm going to go into crowdsourcing security data through MHN and talk about some of the data that we've been able to collect and show you some examples. Then I'm going to go into lessons learned about building this project in this community. We have an announcement to make, and then I'm going to close with some demos. Okay, so what are honeypots? Honeypots are software systems designed to mimic vulnerable servers and desktops with the goal of being used for bait, or to slow down, or to detect hackers, malware, or misbehaving users. They're designed to capture data for research, forensics, or threat intelligence. In this talk, when I mention honeypots, I'm talking primarily about low interaction honeypots, not high interaction honeypots. The MHN system is built entirely around low interaction, so just keep that in mind. All right, so why honeypots? Honeypots are the cheapest way to generate threat intelligence feeds around malicious IP addresses at scale. There's really 3 deployment models when you think of honeypots, and they all have 3 different uses. So one is internal deployment. So this is behind your firewall. Deploying like this is really good for contributing to your overall security of your internal network. Provides a low noise IDS sensor. We have a company that we've worked with that have deployed about 50 honeypots on their internal network, and they said they actually get 2 to 3 events per month, which is really, really low, but the events are all high quality. When they get an event, they act on them. Local external deployment, so this is deploying honeypots on your IP space, but outside your firewall. So this is good for answering questions like, who's attacking me? You're going to get some noise with this, so you're not going to want to respond to every event, but it's useful data, especially if you combine it with the third type of data, which is global external deployment. And this is what ThreatStream does, and this is what the MHN community provides. So this is where you deploy these honeypots far and wide on rented servers, cloud servers, other people's networks. And this allows you to answer the question, who's attacking everyone? Lets you see global trends. And when combined with local external deployment, it really is useful because it enables you to say, is this IP attacking just me, or are they attacking everyone? Which can guide your decision on what to do with them. So another kind of justification for honeypots. Did anyone here go to DerbyCon or see this talk at DerbyCon this year? This was a talk given by Catherine Trame and David Sharp. They're from GE's CERT team who does APT hunting for GE's network. So in this slide, they talk about the types of attacks that their team responds to since 2011. And by the overwhelming majority of attacks they responded to were from internet-facing assets. So I think this slide alone really justifies using and deploying honeypots outside your firewall on your network as a way to detect these guys trying to hit your internet-facing assets. All right, so what is the modern Honey Network? It's an open source platform for managing, deploying, and then leveraging the data from honeypots, either at scale or deployed on your enterprise network. The goal of the project was to make deploying honeypots and exploiting their data as simple as possible. I'm not going to demo the deployment today, but typically deploying a honeypot means you deploy the MHN server one time, somewhere on your network or on the internet, and then from there you can deploy honeypots typically in about 2 minutes using a single command. It's pretty easy. This system leverages several existing open source tools, including HP feeds, which is a transport mechanism for how the honeypots transport data back to the MHN server. Nemesine, which is an open source project provided by the Honeynet project that's used for taking HP feeds data and indexing it into MongoDB. Honeymap, same sort of thing, project provided by the Honeynet project. It's for visualizing this data in real time. Most of you have probably heard of MongoDB. That's the database MHN uses. And then we have several honeypots and then also generic network sensors that we've written support for, including Dionaea, Conpot, which is an ICS honeypot, Snort, which is not a honeypot, and Suricata, which are really good when paired with honeypots for seeing what sorts of tools the attackers are using against the honeypot. Kippo, POF, or passive OS fingerprinting, also really good when combined with low interaction honeypots for gleaning just a little bit more information about those that are interacting with it. Glastopf, Amun, Wordpot, and then Shockpot. Shockpot's a honeypot that we released during the week when the shell shock vulnerability was announced publicly and everyone started scanning for it. It's a honeypot that's designed to respond to shell shock attempts for exploitation and downloads the payloads associated and then brings those payloads back to you so you can do analysis on them. Okay, so here's the architecture for what MHN looks like. The top section of this diagram is the MHN server. So this is what you would deploy on your network. The bottom section are the other components. So starting at the bottom with the sensors. So for example, we have Conpot, Dionaea, all the other sensors I mentioned before. Those are sitting on your network, collecting data, and shipping it back to the MHN server using HP feeds. From there, HP feeds is sending this data in real time to Honeymap for real-time visualization, to Nemesine for indexing this into MongoDB, and then also to HP feeds logger, which is a component that we wrote that's useful for integrating this honeypot data with external security systems. And we currently have support out of the box for Splunk, ArcSight, and then Logstash, so you could really build your own sort of system. Moving around this diagram a little bit more, I mentioned all the data is stored in MongoDB, so it's broken out and normalized into a bunch of different models, one for sessions, one for URLs, one for files, and a handful of other smaller ones. We built web apps, a web app around all the data in MongoDB. This gives a user an interface to explore this data, as well as set up and deploy honeypots and then manage them. And then we also have REST APIs for exposing this data to other applications, and then for integrating with third-party applications, that want an API. And ThreatStream actually uses the REST APIs for our product Optic. That's how we consume the data out of our MHN instance. Okay, so MHN is also a community of MHN servers that contribute honeypot data back to the community. MHN servers and their honeypots are operated by different individuals and organizations ranging from students in academia to we have some energy companies, some big retail organizations, some technology companies, and then there's a ton of users who deploy these on residential broadband or cloud-hosted environments. Sharing data back to the community is optional, but if you do share, you get access to our aggregated data on attacks. And we're currently working on a way to share data at a more granular level, including the actual raw event data. We're just not there yet. So here's what the community looks like. So at the bottom, we have all the honeypots. And notice there's a whole bunch of different types of honeypots. So these deployments are really up to the users who download MHN. They can deploy whatever they want. So they can build support for a new sensor that we don't have support for. include an MHN and share the data back if they're interested. These MHN servers get deployed really wherever you want. And if your data sharing is turned on, it submits statistics about the attackers back to the community. And those statistics are rolled into files, which we share on opendata.threatstream.com. And anyone who has deployed an MHN server, we can verify that they're sharing and requests access. We'll give them access to all this data. And we have data going back to June 1st of 2014. We intend to keep this going. Okay, so now moving into some community stats. So just here's some numbers that are kind of centered around the community. Since this project has started in June 2014, we've collected nearly 270 million events from these heterogeneous honeypots deployed by other people. Typically, we see about 1.2 million events per day, coming from about nearly 3,000 honeypots and nearly 300 MHN servers. And when I say nearly 300, we're not really sure exactly the exact number. If we can see the IP addresses of the MHN servers submitting data back to us, and if you aggregate those by /16, there's 286 of them. If you just take the raw IP count, it's 428. So the number is somewhere in between because of DHCP churn. So we're not really sure. These servers and honeypots are deployed across 42 countries and 6 continents, which is pretty amazing if you think about the global spread that this project has gotten in really less than a year's time. A little bit more stats on some of the sensors. So we've had roughly 2,000 sensors submit 100 or more events. We've had roughly 1,600 sensors give us 1,000 events or more. Roughly 963 have given us 10,000 events. 381 have provided over 100,000 events. 62 sensors have provided more than 1 million events. And then 2 sensors have provided more than 10 million events back to the community, which is pretty interesting. Here's some stats about the actual project. So MHN is an open source project using the LGPL license. We have 12 contributors who've contributed code back, and we've merged their contributions back in pull requests. There's 74 forks on GitHub, 459 stars. We have a really active Google group for this project with 64 members, 135 topics, and 461 messages. So we probably get a few messages per day. They kind of spike here and there, but it's a very active group. So if you're using MHN and you need help, definitely ping the group, and we'll try and get back to you. This slide shows the growth of sensors over time. So this is the number of sensors added per day. That huge spike is kind of interesting. If you look at before the huge spike, it was relatively flat and actually very low, like only 1 or 2 sensors were being added per day. The time frame around that huge spike was at the end of September, early October. Does anyone have any idea what might have caused someone to deploy roughly 200, and I think it's about 220 over the course of 2 days, 220 honeypots in that time period? Say it again. It was actually the shell shock vulnerability was announced. People started scanning for it, and then things started picking up, and we're speculating as to why this is, but the timing is just too coincidental. If you look at sensor growth of the project since then, it's crazy. Before shell shock was announced, sensor growth was really low. Since that day, it's really gone up and up and up and up. We have nearly 3,000 sensors deployed, or we as a community have nearly 3,000 sensors deployed now. Here's a slide showing the number of events contributed per day. That huge spike is actually not correlated with the growth in sensors that I showed you earlier. It's actually 2 weeks later. And when I saw that, I thought it was pretty suspicious. And in fact, if you dig into the data a little bit more, and we look at the attacker IP address from those attacks, that humongous spike was from an RFC 1918 attack, 1918 IP address, or private IP space. So looking into the data, someone had set this up locally and just had one server pinging the other server, probably for some sort of a demo purpose, but it ranged over the course of a couple days. So it's definitely some noise, but interesting nonetheless. Events per honeypot, so that humongous spike, it was actually Dionaea, so someone set up Dionaea honeypots internally and just started pummeling them. If you look at these stats, Dionaea is definitely the #1 honeypot that's deployed out in the wild. at least contributing back to MHN. Kippo is a close second. Kippo is probably my favorite honeypot, just for the sorts of data you can get from it. I think it's really fun to kind of just look at the command logs of what the attackers are doing. Amun is the third one, which I thought was actually kind of surprising since we added support for that fairly late. And then Snort, POF, and then the others. Here's another view of the data. So this is events by honeypot showing percentage of the events. So, like I mentioned before, Dionaea is number 1. But really I kind of wanted to show the purple, 3.9% contribution is from, it's one of the smaller ones. It's from NS Focus Honeynet events. So NS Focus Honeynet events is not something that MHN ships with. It's not a honeypot we support. It's a honeypot that someone added support for. We don't know who exactly, but if you Google that, there's an Asian company here provides a product that's called NS Focus Honeynet. So we thought that was kind of interesting. They integrated it with their instance of MHN and shared their data back. Events by attacker country. Not surprisingly, the US is number 1, China's number 2, France, Hong Kong, and other major countries follow. Notice the RFC 1918 spike is gone here because these are all events where we could correlate with IPGeo. Events by attacker country, same sort of information, just displayed differently. Okay, so from this project, we've learned a lot. And one of the goals was collecting security data, and we were, I'd say, pretty surprised with how large this project has grown in the time frame it has. But I think it really shows the merit of crowdsourcing data, especially security data. The term crowdsourcing was coined, I think, in 2005. So it's the process of obtaining services or ideas or other content by soliciting others to contribute it back, typically either for free or for money. There's a ton of benefits to doing this. So one of them is diverse perspectives. So if you're to think about trying to deploy 3,000 honeypots deployed across the world, the cost of one organization trying to do this would be pretty tremendous in terms of time and money to get all these diverse locations. But if you crowdsource it like we did, we're able to get tremendous distribution of these sensors with very little cost. Diverse data collection, so people are choosing which sorts of honeypots they want to deploy. So they're deploying what's most meaningful to them and contributing their data back. So we get diverse data. We distribute the cost of this project in terms of the money, the time, and energy across a huge community. Like I mentioned before, without the crowdsourcing of this would have been a tremendously expensive project to work on. And then lastly, provide this data back to the community, especially for research. It has a ton of useful data. All right, so some lessons learned from building this project in this community. So we found that a lot of people really like honeypots. I talked to, I think, about 5 people so far just today that have deployed MHN and have talked about how much they liked it, or like the ability to deploy honeypots quickly for research or for integrating with their security. I feel like one of the primary motivating factors behind this is the visualization it provides. And I'm gonna do a brief demo later, but if you give someone a threat map where they can put their own relevant data on it for free, they're likely going to use it because it's cool and because it looks good on their ops floor. Lots of organizations will share their data back with you if it's part of a community. I was also kind of surprised at this piece of it, that so many people are sharing their data back. I've only talked to a couple organizations who decided not to share their data back. There could be more, but it seems to be the more rare of the users using this project. And then lots of companies will deploy honeypots in production on their networks, especially if you give them a way to manage them and a way to integrate them with their existing security products so that they can actually use the data. This was a big piece that was lacking, I'd say, before our project started. There was very little way to easily integrate these with your existing security products. So people would set them up and they'd kind of have to write scripts and duct tape things together to get them to work. But our goal is really to make that easy. More lessons learned. There are going to be a ton of beginners, not just with honeypots, but beginners with Linux or security who come to you when they set these things up. If you're trying to start a project like this, I would just recommend be as patient as possible. The scope of support you're going to have to provide is going to go well beyond your project. We have done that here and there, providing people who are trying to set MHN up with helping them troubleshoot their network, or they have a misconfigured Linux system, things like that. Courtesy can be lost in translation. Because this project is so widely spread, there's a lot of people who use it that don't speak English. So we've had quite a few people who've used Google Translate to write their question, translate to English, and submit it to our list. And sometimes these questions can come off as terse or almost rude. So I would say as you grow a project like this, keep that in mind. Don't take offense. It could just be an artifact of Google Translate. Create a frequently asked question as soon as possible and populate it. This is something we did not do immediately, but we probably did it after about 2 weeks of having the project, and it has saved so much time in terms of troubleshooting and responding to the same problems that occur over and over. We had a teacher assign their class setting up MHN and deploying Honeypots as a class project, and this kind of bombarded me in particular with support requests. So the FAQ was tremendously helpful in that case, so keep that in mind. This is an obvious one to probably everyone here, but make it clear users need to provide logs if they want help. We get a lot of requests that just say, hey, it's not working, can you help? As the first request, when they really should just be sending their logs as the first request. We're still kind of working on getting that right. Be appreciative of people who report bugs. So we are definitely mindful that people running this project come from all sorts of places, from hobbyists to students to people in big companies. And a lot of them are running this on their free time for fun. So if they find a bug, I imagine it can be tremendously frustrating to them. So be appreciative when people actually report bugs, fix them, encourage participation, and then get feedback from your users and try and incorporate it back into the project. All right, so now I want to move on to an announcement that we want to make. So today we released an MHN Splunk app. It's free and open source. So what this allows you to do is take all the data collected by MHN, put it into your existing Splunk installation, and then explore this data, analyze it. We have dashboards for doing that, and then you can also build alerting on top of Splunk, which if you haven't used Splunk for alerting, it's really easy. So this is a really awesome kind of integration piece that is, if you don't have a tremendous amount of honeypots, you can operate this all for free using the free Splunk edition. I think it's less than 500 megs a day of log data, which that's quite a bit of honeypot log data if you're going to start generating this. The other thing it provides is pivots to virus total hash, and dshield. So we have all this data coming in. We figured we might as well give you other pointers of other places to go look and get more information. And then lastly, we use Splunk's common information model to do this. So if you're using, I think, Splunk security or enterprise security, you should also be able to take the honeypot data and use it with other reports and analytics. So all right, now I want to drop into some demos, and then after that, I'll wrap up. Okay, so this is the MHN dashboard. So before, actually 2 days ago, I decided to deploy a demo version of this, really because in going through this demo, I would expose some of the honeypot IPs. So I didn't want to have to worry about hiding them from our production instance. So to set up this demo, it took me about 1 hour, including the time to install MHN, install Splunk from scratch, install our Splunk app, install honeypots on 5 servers, and get it up and running. This is the dashboard. So this is when you would log into your MHN instance. This is what you'd see. So it gives you just a summary of what MHN has seen from your honeypots. So it gives you the top attacks, the number of attacks in the past 24 hours, the IP addresses that are involved in those attacks, the ports involved, and then if you have Snort or Suricata deployed, the signatures of the top ones that it's seen. We also have HoneyMap. So HoneyMap is the Honeynet project for visualizing this data in real time. So reload this. And hopefully we'll see some attacks come in real time. If not, it might be a little boring. But here we go. So this is the, I would say, thing that drives a lot of people to actually set up MHN initially and put this on their SOC or their ops floor. You can, it's relevant data to your organization. It's kind of a cool visualization, but it's just a piece of the project. From here, some other things that are available. So we have the attacks page. So this is just a very simple way to kind of explore the data, search it, look up information about an IP address that might be attacking your network or showing up in other logs that you have. The goal of this piece was really just bare bones and simple exploration. The Splunk app kind of surpasses this greatly now. So if you want to do anything hardcore, I would highly recommend either using the APIs and writing it yourself or using the Splunk app and using the dashboards. This deploy page, this is probably what makes MHN easy. So what we've done is we have taken all the top honeypots that we're aware of, and we've written installations for them. So this will bootstrap the process of downloading all the packages, downloading all the dependencies, installing the honeypot sensor, doing a key exchange with the MHN server, setting up HP feeds, getting data flowing, and then lastly, deploying the honeypot using supervisor D. So this is a Python system that's meant for managing processes, and if the process dies, it automatically restarts it. So it's a way to kind of add another layer of reliability to honeypots. So we've done all of that work for all these different honeypots, all the ones I mentioned in the slides before. From here, the way this works is you would select the honeypot you're interested in deploying. So say we want to do POF, so this is not a honeypot but a sensor. You'd copy this command and then paste it into a terminal on the server you want to deploy this to. And it does all the steps I just mentioned, gets everything flowing, and everything starts working. Well, we also have just some other kind of management type things. So this is the list of all your sensors. You can see the counts of the attacks that the sensors have seen. This shows you really, are the sensors alive? Are they collecting data? If you see all zeros there, it means something's wrong. For example, we have a 0 here for my Wordpot honeypot. I'm not sure why that is, but that shows that something's wrong. And then lastly, these charts. So these charts were contributed by a third-party user. So he wanted a way to visualize the Kippo data. I guess you can't see them very well. But these charts show the top usernames and passwords entered by attackers into Kippo, and then the top attackers. So it's kind of cool. User contributed, looks nice. Now that we have the Splunk app, it kind of, you don't need this as much, but regardless, it looks really nice. All right, so now I'm going to move into just showing some of the Splunk app. Okay, so the Splunk app's goal was to provide you dashboards that show you, what's going on with your honeypots. The overview page shows you kind of at a glance what's going on with all of your sensors and shows you some stats compared to 2 different time periods. So at the top, you'll see all the counts of attacks or unique attackers or unique MD5s or URLs or commands executed for today, and then those little numbers or percentages show you a comparison to how they were yesterday, just to show you some basic trending. We also have trending of all the events going through all your honeypots. We have a map that shows you where the attacks are coming from for your honeypots, and then a bunch of charts and graphs. Hope you can see these, showing the top attacking countries, cities, honeypot types, ports, and then charts that show the top attackers, the top attacker OSs. This is pulled from passive OS fingerprinting, top usernames and passwords, things like that. I think this chart is kind of interesting. I'm not sure if you guys can see those green lines, but that's an activity graph involving these IP addresses. So it shows you kind of at a glance how much this IP interacted with your systems. So this IP and this IP at the bottom, you see have a pretty jagged chart. So this means they're pretty much constantly interacting with your systems. And the bottom one, when I was preparing this demo, I did a little bit more research, and it's been pinging one of our sensors on port 1095 every 2 minutes. I'm not really sure why. It seems like it's just a misconfigured system, but it shows up in this graph, and it's kind of interesting. Moving down, we provide a bunch of other stats. Your top sensors producing data, the top MD5s that we've seen, top URLs, and then top signatures seen from all the Snort or Suricata instances you've deployed. That's the overview page. We have a bunch of other pages really centered around the specific types of honeypots. So if you deploy Dionaea, you'll see all the data that your Dionaea honeypots have collected. And like I mentioned before, for example, for the top MD5s, you have pivots to total hash and to virus total. And then for The top IP addresses, same sort of thing, pivots to dshield. Every page, I'd say, kind of looks the same or has the same generic template. Event counts at the top, raw events at the bottom, and then highly relevant graphs in the middle, showing either tables or graphs with data that's related to the honeypot. Let me show you one of the other kind of interesting ones. So Kippo is an SSH honeypot. This allows you, this attracts attackers to try and SSH into your system. You can set up usernames and passwords. Typically, you want to make them fairly weak. So in this case, I think our username is root and our password is 123456. And just setting this up, we've had a bunch of logins and attempts to download various URLs and I would guess execute them. We also see the top SSH version strings and then top attackers. The last one I want to show you is Conpot. So Conpot is an industrial control systems honeypot. Its goal is to look like an industrial control system and have people attempt to run either commands or fingerprint the system. It collects some interesting data, and we build a dashboard around that. So let me go back to my slides. Okay, so like I mentioned at the beginning, everything I talked about here is open source and free. So here's 4 of the projects that ThreatStream has authored for this project. So the MHN Splunk, our HP Feeds logger, which is the integration with ArcSight and Splunk, and then Shockpot. ThreatStream is really big on open source. If you go to our public GitHub page, we have 24 public projects. 10 of them are original ThreatStream projects that we have released open source, and the 14 others are projects that we forked, contributed data to, and then either made pull requests to the original owner, or just put the code out in a branch for the public to use. Before I wrap up, I just want to say a big thanks to OpenDNS for hosting this. This is an awesome place to host a conference, and thanks for all the food at the food trucks. It's been great. And then I want to thank everyone on this slide. So everyone on this slide has either contributed code in some way, helped promote the project in some way, or has been a very vocal user who's provided us with a bunch of feedback, and I just want to say thank you. I would say especially thank you to the Honeynet project. They produce a ton of awesome packages for honeypots. In fact, most of the stuff that we use through MHN is from them. If you use honeypots, I would highly suggest that you make a donation to the Honeynet project, and just thank them. Any questions?
We actually have a mic now, finally, for the questions.
So, question and a comment. This is a great project. Using the scripts makes it stupid simple to set up a honeypot and get it running. So I really appreciate all of your work and your team's work with those scripts. And then question, theoretically, if I was like a company, I would be kind of worried about setting something up like this in my company network because what if one of the sensors is breached and an attacker uses that server to launch attacks? That the company could be liable or suffer damages. So how would you respond to that?
That's a good question. A lot of these honeypot projects, if you look at the code, they're fairly well written, and they're really designed to look vulnerable and to serve one single purpose. So they do one thing and they do it well, and they do it in a limited fashion. So I'd say the risks are fairly low. Every one of the honeypots that we deploy is a low interaction one, so we're not letting the attacker actually get operating system access, so it's not like we set up a real Linux server where they actually really get to log into the Linux server. So I think the risks are fairly low. We've had a number of companies who have felt comfortable deploying these, and so far it's worked out pretty well. We haven't had any reports of vulnerabilities being exploited related to these honeypot systems. Doesn't mean it hasn't happened, but we haven't seen anything like that.
Down here. So I was curious, right now it's done by scripts that you just kind of throw into a host. I'm curious if you have any plans to integrate with things like Docker, containers, that sort of thing that makes it even easier. But are there plans for the future for something like that?
So we've tried using Docker for some of these honeypots, and the installations fail for a couple of reasons. So one is a lot of these, so Dionaea, POF, Suricata, Snort, they all need direct interface access. And with Docker, Docker has a way to do that, but for some reason it is incredibly slow, and you'll drop like 50% of the packets. So we tried doing that, and it just did not work very well. For the other ones where they're just really applications that listen on a port, Docker would work really well. We probably should go down that road. But I would say until Docker has better support for raw, packet sniffing, that we probably want to wait.
So the comment about letting other people run software on your network applies to any software that you run on your network that's other people's. And there's nothing that keeps you from putting it on a guest VLAN that has no access to your production facilities. But, just like your guest Wi-Fi wouldn't have access to your production facilities. So, don't worry about that too much. That's just my comment.
Anyone else?
You mentioned pulling in information from like VirusTotal and other hash information. Is there any information going in the reverse? Are you guys providing any threat intelligence data or research from this to any kind of like threat streams or research organizations?
So currently, with the community contributed data, you have to be kind of in the community and a contributor to get access to it. We're not currently providing the data to any other security company. If someone from one of those companies has set up MHN and asked as an individual, we've given them access. But as far as we know, we haven't given it knowingly to another security company. We're definitely open to sharing this data with really anyone who's willing to share back. Does that answer your question?
Anyone else? All right. Thank you very much.
Thank you.